Okay, in this video we want to solve this first order homogeneous differential equation. It's given as dy over dt is equal to y squared minus 3ty plus 4t squared divided by t squared. And for first order homogeneous, what we do here is say that v is equal to y divided by t, and dy over dt is equal to dv divided by dt times t plus v. So this is important to remember if you're going to solve a first order homogeneous differential equation problem. And so for us, what we're going to do is write this in a form of v. So if we say dy divided by dt is equal to, we have y squared divided by t squared. So instead of that, we can say y divided by t parentheses squared minus 3 is on the outside of t times y divided by t squared. This would give us, this t would be eliminated, and we would get y over t plus 4t squared divided by t squared would be 4. So this is what we're going to say. And now the next thing we do is we replace yt with our reference of v, and we replace dy over dt with this. And so we can say that dv over dt times t plus v, so this right here, is equal to y over t would be v, so we can say v squared minus 3v plus 4. Next we will eliminate this plus v, and we'll say minus v here, and so we would get dv over dt times t is equal to v squared minus 4v plus 4. Next, we're going to want to combine t with dt and v with dv. So in order to make that happen, if we divide everything by 1, like we can say instead 1 over t, like we flip it, we would have to flip this also. So we would get dt over dv, and by flipping it we also have to flip this, so we would get 1 divided by, but we can actually factor this out. So we can get v minus 2 times v minus 2, like this. And next we will say integral of 1 over t dt is equal to the integral of v minus 2 raised to negative 2, it's equivalent to this, times dv. Okay, next we take the integral of both of these, and so we would get ln absolute value of t plus c is equal to, we would get negative v minus 2 raised to negative 1. We would also have an arbitrary constant c here too, but it wouldn't be plus c. You could say plus d. But instead of doing that, we just say plus an arbitrary constant on one side. We can choose this side or we can choose this side. I chose plus c on the left. And the next thing we're going to do is distribute the negative. We want to remove negative here. So we can say negative ln absolute value of t plus c is equal to v minus 2 raised to negative 1. And we will eliminate this negative 1. We can say v minus 2 is equal to, we will flip it. We'll say times negative 1. If we do times negative 1 here, we have to do it on this side. And we would get negative 1 divided by ln absolute value of t plus c. Next we would distribute this negative 2. We'll say plus 2 here. And so we would get v is equal to negative 1 divided by ln absolute value of t plus c plus 2. And let me go back to the reference we had earlier. In the beginning, we said that v is equal to y divided by t. And so we will replace v with y over t. So instead of v, we will say y divided by t is equal to negative 1 divided by ln absolute value of t plus c plus 2. And so our final answer we could say is y is equal to negative t divided by ln absolute value of t plus c and plus 2 on the plus 2t. And we will box this answer in. And that's all we need to do for this problem.